Well, buenos dias. Unfortunately, that's almost all of my Spanish. There's about 2 more phrases I do know. So your English is much better than my Spanish. My name is Rebecca Parsons. I'm here to talk to you about a concept called evolutionary architecture. And what I want to do is start with making sure you understand why this is important. And then I want to define evolutionary architecture. And I'm going to cheat and not define architecture, but I'm going to define evolutionary architecture. And then I'll talk through some of the principles that underlie it, and you'll actually see there's a lot of parallels between evolutionary architecture and the agile principles as they are applied to software development. And then some underlying techniques that actually make this happen. And then how to actually make it work in practice. In particular, if you're like most people in our business and you're starting with a brownfield, you're starting with legacy, you're starting with a big ball of mud. So why should you care? The expectation for the rate of change is dramatically increasing. We can't get away with saying, oh yes, you'll have your system in 3 years. We used to be able to do that, and you can't say that anymore. If you can't get them something in 3 months, they're starting to look at you as if you're crazy. Even business model lifetimes are shortening. When you look at the length of time organizations are on the top of the stock market charts, companies are just plain going out of business because the fundamentals of their business have changed. We had a client in Australia, and they went in the course of 6 months from having their prime asset, which was their underwriting model for their insurance policies. It was their prime asset, their money maker, and it went to be a boat anchor because all of a sudden somebody got the clever idea to quote insurance online, and their model required 87 parameters. How many of you would spend the time to type in 87 fields just to get an insurance quote? Their complete business model dropped out from under them in the course of a few months. And of course, it's harder to predict the future. It's never been easy, but when technology was changing as slowly as it was, you could have a sensible 5-year technology roadmap. It's only been 11 years since the iPhone was introduced. Think of all of the changes that have happened. Think of what's happening even if you don't use Docker yet, what Docker is doing to the overall architecture space. And for those of you who are in startup land, if you miss your minute of fame, if for whatever reason you can't adapt to take advantage of that viral moment, you've lost your chance. Because not only have broad business model outcomes, that their time frames have shrunk, but even those windows of opportunity have gotten smaller. So how might we solve this? This is not a silver bullet, but evolutionary architecture can help. And here's our definition. So evolutionary architecture supports guided incremental change across multiple dimensions. And I want to focus on 4 words here. The first is evolutionary. This is not an adaptable architecture. When people say adaptable or words like adaptable, they imply there's an adapter. There's something that you can allow it to change. Maybe it's a configuration parameter, maybe it's an abstraction layer, but you've done something to make your system adaptable to a particular kind of change. But that's not what we're talking about, because we can't predict the kind of change. So let's say you did make it adaptable, and you did all the work to build this adaptation framework, and then your change comes in sideways. And now what do you have? You have more code that's more complex, because the easier it is to reuse, the harder it is to use. You've got more bugs because you have more code, and chances are the change you actually have to make is going to be harder because of all that other stuff that's there. That's not the best way to go about doing things. So we're focusing instead on evolutionary, which hopefully implies you live in an environment and you have to respond to whatever is happening in that environment in whatever way you can. You're not predicting the changes. You are making yourself as ready as possible for whatever change actually happens. Guided. To me, this is the most important point from this talk. There is no such thing as a good architecture for every system and every application. We can probably all agree on what constitutes good code. When Neil Ford and I first started talking about these ideas, he was calling this emergent architecture. And he and I had a very vigorous debate about why he was wrong to use that word. Because emergent implies ad hoc, and I'm just going to explore. I call it evolutionary because we are setting out for our particular organization and application what constitutes good. Let me give you an example. I worked several years ago on a trading system. People hear trading system, they think high latency, high throughput, low latency. Got to move fast. This organization, in its wildest dreams, didn't expect to do more than 100 trades in a day. They didn't care about latency. They cared about never losing track of a message because every one of those deals was worth billions of dollars. So you couldn't say there's a perfect architecture for a standard trading system and this other trading system. They have completely different fundamental requirements. When we say guided, we are saying, look at your ilities. Do you care more about scalability or security? Do you care more about resilience or maintainability or uptime? All of those different ilities. You want to pick for your system, for your organization, what is the important characteristic that ensures success of your system and that will fundamentally drive all of your different architectural and design decisions. Incremental change should be obvious, but we want to be able to change aspects of our architecture and our system that people didn't really think about changing. You should be able to take out your middleware layer. You should be able to take out your persistence framework. Incrementally, making the changes that you need to make in order to keep your system ready for change. And then across multiple dimensions. These ilities all interact with each other. You cannot both maximize performance and maximize security. You can't do it. Because if you're going to maximize performance, you don't want to spend as much time running encryption and decryption. You can't maximize both. So you have to decide, what is the level of encryption that I need? What is the level of performance that I can tolerate? What are those things and how do they interact? Because it's not just a single dimension we're concerned about. We're concerned about all of the ilities and how they interact with each other. So now, here are our principles of evolutionary architecture, and I'm going to go through each one of these in more detail, but this is about when and how we make decisions. This is about how we actually work with the system. This is how we also think about those pesky people problems. Because unfortunately, this isn't just about technology, this is also about people. So the last responsible moment, this is really about how you prioritize decision-making. When you make decisions, you want to delay these decisions for as long as possible, but no longer. Because the longer you wait, the more that you know. And this actually minimizes a form of technical debt that can come from bringing something into a system that is more than you need. Now, of course, the question becomes, how do you determine when's this last responsible moment? And that goes back to what I talked about earlier. What are the architectural drivers? What are the things that are going to have the greatest influence on the design and implementation of your system? And you're going to prioritize decisions that impact those. And to the extent possible, this has to be evolutionary, not emergent, I'm just going to respond, but also not trying to predict the future. Because you can't. You cannot predict where the sources of changes are going to come from. Now we want to think about evolvability as a first-class citizen. And in fact, we're asserting that evolvability is another one of those ilities, which you would prioritize. In a system that's small enough to throw away, don't worry about evolvability. If it's small enough to throw away and something major changes, throw it away. This doesn't have to be prioritized above all. And one of the ways that we found, particularly for business applications, that makes it easier to change the system in the ways that you get asked to change systems is to architect it along the same kind of boundaries of the way the business operates. Don't think about package boundaries. Think about conceptual boundaries, domain-driven design, all of those different concepts. Because if your systems can adapt to match the way the business functions, that information flows through the business, the kinds of changes that your business users are going to ask of you, it's going to be spoken in that language. It's going to be crafted in that conceptual term. And the closer your systems reflect that conceptualization of the business, the easier it is going to be for you to change it. And please, let's not forget about data lifecycle and ownership. The way we get ourselves into inadvertent coupling because the way we think about data is unbelievable. One of my more embarrassing, the fact that the meeting had to happen, fortunately it wasn't a bad meeting, I had to meet with the global CFO of a Fortune 5 company. And this was 10, 15 years ago. But the reason I had to meet with him was he was the only place in their entire organization where they could get sign-off on a data migration for a relatively unimportant system. The first thing he did was say to his executive, his TA, you work with her and go fix this problem, because this is not what a global CFO of a Fortune 5 company should be thinking about. And number two, get me the CIO. I want to understand why we got to this place. So think about data. Appropriate coupling. You can't talk about architecture without talking about coupling. Sometimes it's loose, sometimes it's tight. Think about, for the different aspects of your system, what is right. Where possible, use the lightest weight tooling and documentation as you can, because the more something brings in, the more parts there are going to be that affect it. And now, what does it mean to actually develop for evolvability? The first thing is a code base is not going to be evolvable if you can't understand what it's doing. So you need to think about software internal quality focused on understandability. How easy it is to figure out what that piece of code does so you can do something with it. And as much as I'm a purist, and I would love to say no bad code should ever be allowed to live on the face of the planet, that's not the reality. So find your hotspots. Yes, run your metrics over all of the code base. But then look at some other factors. When do your operations people get nervous when you say you're going to change a part of the system? Where do your defects come from? Where have most of your changes been? Prioritize your efforts there. You might have a steaming pile of mud over here, but if you haven't had to change it in 5 years, hopefully you won't. And so you can just leave it over there and leave all that problem behind. But you need to continually measure your quality so that you know when something's going horribly wrong. If you've got metrics that are bopping along on here and all of a sudden it plummets, you know there's something that happened right there. Now, maybe you've entered into a particularly complex part of the system, or maybe you've got a new project manager that's being overzealous and pushing the team, and so internal quality is suffering. There are all kinds of reasons, but you need to know that. The actual trends are far more interesting than the actual numbers. And think about reversibility. I've heard it asserted that all design decisions should be made easily reversible. And that violates Yagni in all kinds of ways. But there are going to be key decisions that for whatever reason you feel like you have to make too early. So pay that little extra cost to make that decision as easy to reverse as possible. Maybe it's building a different kind of abstraction layer. Maybe it's doing a little bit more parallel development. But think about what it takes to actually make that reversible. And now, how do systems interact with each other? Because as Gregor Hope once pointed out at a talk, an architecture diagram is not an architecture diagram if it only has boxes. It needs to have lines. Architecture is as much in the way the different parts of your system communicate as anything else, and that's where Pastel's law comes in. You want to be conservative in what you send because you're making a promise to people that you're going to send that, but be as liberal as possible in what you receive. Don't validate something that you don't need. Caveat, make sure you don't open yourself up to any security holes. But this holds for any kind of information exchange. People normally think about it in terms of messages, but we've seen people get themselves all tangled up in databases because they're all coupled through databases. So think about this for any information exchange, and think about when you might want to preemptively start using version numbers because you think it's just too vulnerable to change. I'm from ThoughtWorks. We have to talk about testing. But actually what we found is if you think about the testability of a system at an architectural level, you end up with a clean architecture. Because thinking about testing pushes you away from things that also get you improperly entangled. Messaging infrastructure used for business logic. It's very difficult to test those things. We prefer very dumb pipes. Put the logic in code where we know how to test it. This is, again, where thinking about how your system works more from the business perspective helps. There's a CEO of a mid-sized company, and he reads all of the acceptance tests every month for his product. He can understand them. He can look across the room and see the build light is green. But what he told me was the reason he does it is that way he knows what his product actually does, because it's right there in the tests. And he can even pick up the subtleties because that's the way the system was architected and the tests were constructed. And of course, testing at all levels. I'll talk more about contract testing. And really to do this, you need a build pipeline. You don't want this scale of testing being done by manual testers. It just doesn't make sense. And now the people problem. Conway's law basically says that any organization is going to construct systems that correspond to their internal communication structures. And I've seen many, many attempts to work against Conway's law, and they all fail. Conway is going to win. I get lots of points when I walk into a new client, and I spend a few hours and then say, that integration over there is broken. And they say, how can you know that? You've only been here a few hours. I watch how the people interact. When you've got people walking like this when they see each other in the hall, I can guarantee you that integration doesn't work because they're not talking to each other. So you have to think about how your system is structured, how your organization is structured, and how those silos work. And if you don't want a system like your organization, change your organization. That's the only thing that's going to work. So now, how do we actually make this happen? And each one of these 4 things is at least a day-long workshop, if not a week-long workshop. So you're not going to come out of here knowing how to do these things, but you need to be familiar with all of them. To me, across all of the roles in the software development lifecycle, the role that had the most legitimate say of Agile doesn't work for me were the DBAs. Because data migration is hard. It's conceptually simple. I'm going to copy this data from here over to here. It never works. Database refactoring, this was published probably at least 10 years before its time, takes on that problem. By decomposing those large changes into very small changes, where each change shows the change in the data, but importantly, the migration for that one aspect of the data. And so then, just like with continuous integration, we can run these very small migrations and find out, okay, well, this one fails because of this weird flag that existed for some 15-month period of time a decade ago. And this other one failed for this completely unrelated reason. So you decompose this, and then you recompose them all to do the full migration, to do the full data transformation. The subtitle for this book, the title is Refactoring Databases. The subtitle is actually Evolutionary Database Design. And this is one of the most critical things that we need for evolutionary architecture, because you cannot evolve your system if you can't evolve your data. So that is critical. And this works whether you've got relational databases, whether you've got flat files. You have to think about what those fundamental refactorings are, but it works regardless. Next, continuous delivery. When I first started talking about this wacky phrase, evolutionary architecture, I would have people come up at the end of the talk and say, don't you feel you're being professionally irresponsible for advocating changing something fundamental like architecture? If continuous delivery didn't exist, we wouldn't be talking about a lot of these things, because the rigor that comes when you fully adopt continuous delivery gives you a safety net that you wouldn't have before, because you know what your systems look like. You know you're not dealing with some snowflake configuration over there. You know how the system is supposed to work. You've done these promotions throughout the various environments, and you know how all of that works. You've got all of the automated tests there. Basically, what continuous delivery allows you to do is stop worrying about deployment. Deployments should be boring. You should be celebrating the features, not the fact that this time you managed not to get into trouble. And that's what continuous delivery gives you. It allows deployments to be interesting on business grounds and boring on technical grounds. And that means you can make a lot of changes. You can deliver a lot more than you could in the past, because you can experiment. You can safely deliver. You don't have to worry that the CFO and the CEO are going to come down and yell at you again. Caveat every time I talk about continuous delivery, just because you can deploy at the drop of a hat doesn't mean you have to. The important thing is that you can. And if you read the continuous delivery book, there is nothing in that book that says there can't be a person in the loop with a big green button on their desk, and nothing's going into production until that person hits that big green button. You can put in whatever kind of safety gates you want. It is the fact that a person at 3 a.m. doesn't have to do all of this stuff, that you know exactly how this process is going to go. That's the critical part of continuous delivery. And now choreography. Let's think about how these different parts of our system interact with each other. This is as opposed to orchestration. So I'm going to try to illustrate this. In an orchestra, you have a conductor who stands up in front, and everybody is watching that conductor, and everybody is doing exactly what that conductor says. And if that conductor falls off the stage, the orchestra stops. Single point of failure. There are, in fact, pieces that are designed to have two conductors because the flow in the piece is so different that you need two conductors. Now compare that to choreography. You've got a dance performance. The choreographer isn't up there running around telling everybody what to do. The choreographer lays out the vision. The choreographer explains to each one of the participants what their role is. But it's up to those participants to figure out what to do when something goes wrong. So if 40 years ago I was in a ballet performance and I was going to leap and have somebody catch me, but if that person tripped, I probably wouldn't want to leap. I would have to figure out for myself what to do to get me to the place I was supposed to get to. That's what we're talking about with choreography. This is not as universally applicable as the other things that I'm talking about. But you're scripted to outcomes, not visions. And visions. You don't have this one conductor. So individuals perform, the individual parts of your system conform to this vision and outcome, which means you're distributing the authority. Now, what's the downside? What's the caveat? It introduces all kinds of failure scenarios that simply aren't possible. If you have a strong orchestrator, there are going to be failure modes that you simply don't have to think about. Of course, there are others. But increasingly, particularly when you think about microservices architectures, expanded IoT ecosystems, we are going to have more and more of these independent devices that really do have to work in more of a choreographed style. So as an industry, this is going to become more prevalent. But I'm not telling you to run out and go do this today, because it is more complicated. There are error scenarios that you have to figure out that you simply don't have to worry about in an orchestrated system. And now contract testing. This is one way we start to think about how can we move as fast as possible as an organization. And part of how we do that is we document the assumptions that we are making of each other. So we've got 3 systems, and we each have acceptance tests for the other. We're documenting all the assumptions, and I come up with a suite of tests, and I give them to Maria, and I give another set to Sophia, and then we cheerfully ignore each other. We don't talk to each other. We just keep running our tests. And then my test with Maria breaks, and so I have to go and have a conversation with Maria. Sophia's test didn't break, so we're still ignoring her. She's going off and doing whatever it is she has to do. Maria and I sort out our differences. We get new tests. Sophia's test still passes. We're fine, and we continue. So this maximizes the amount of parallel work that's possible. I don't have to talk to anybody unless I've got a test that breaks. Now, if you do this also in conjunction with Postel's law, you've got a fair amount of independence going on between the different parts of your system. They are only coupled in the way that they need to be coupled. As an aside, probably the single best enterprise architect I ever worked with on any of our clients, this was her role. She understood how every single system talked to each other, what all of their idiosyncrasies are, why you should not do that perfectly logical thing, because they tried that and it didn't work because the systems interacted in ways that nobody understood. These tests can actually document that, and thus you can do lots of work that you couldn't have done in the past. So I'm in a legacy environment. How do I make this work? You can still define this. We call it an architectural fitness function, where you come up and you determine what are the things that are most important, and how will I know when my architecture is achieving that objective. Define this up front, agree it. If you've got a legacy and you know you're way off, pick the thing that worries you the most. Not the thing that you think you're most exposed to for change, but where you're the most worried, and start there. Because just like with continuous delivery, the incremental steps still bring value. You do not have to get to a fully evolutionary architecture to get value from these things. Get your organization more used to delaying decisions. There's usually this upfront period where all these decisions get made, and really the only thing you should be deciding up front are your overall objectives and what your fitness functions are. What are the architectural characteristics that are most likely to determine success? And then understand the different forms of technical debt. It might be the version of particular software you're running. It might be that you're not really using the right tools after all. It might be that you've got a steaming pile of mud over in that corner that you don't have to deal with, but you've got a smaller steaming pile of mud here that you really do have to deal with, because this is where you're going to be focusing a lot of your attention. Understand and manage. Think about all the different places the technical debt comes from. Implement evidence-based reuse. I have met too many architects whose raises are determined by the amount of reuse of the components that they are somehow supposed to magically decide are important by sitting in their office and not talking to anybody. It's madness. You can't know how something's going to be used until you see it's in use. So reuse, if you're going to do it, should be based on harvesting, not speculation, because I've never seen anyone get it right when they've tried to do it on the basis of speculation. And then create and maintain that safety net. That safety net includes continuous delivery, all of that automation. It includes testing at all of those different levels, because you're going to be changing some pretty fundamental parts of your system. And that means errors are going to come from places that you might not have expected them, particularly if you're starting from a legacy environment that is not well understood. Even trying to figure out what the boundaries are can be hard in that circumstance. So start building this up. That's going to be hard too, but the more you progress, the more you will be able to change your system to respond to the opportunities that your organization is looking at, or respond to the threats that they're under. Thank you very much.
Oh.
We should have some time for questions.
We have time for a couple of questions. I don't know if someone has any questions.
Hi. When it's time to take a software that is legacy and make it evolutive in order to prevent further errors or issues in the future?
You're asking what to do with legacy when you need to make it more evolvable?
For example, you know that you have a very legacy software that in the next years will be nearly unusable. So what to do in this?
Well, there are different techniques. If it's a package, that's going to be one thing. You're more likely to put some kind of service layer around it to allow the other systems to interact while you do something with the package. If it's custom, there are different approaches that we've used. You can start to introduce new functionality in the new system and basically have some kind of message router that sits there and decides, does this go into the new system or the old system? That requires you to build infrastructure to allow those systems to interact. Maybe you will start with some subset of your customer base. We're only going to deal with customers that have one of our products. I worked with a telecommunications company that did it this way. You still need some level of infrastructure, but because what happens if somebody buys a second? Now you have to migrate them into the legacy. What happens if they drop one? Do you migrate them back? So there are lots of different approaches. It depends on what you have. It also depends on the complexity that's involved. If there is a way that you can separate things out, we've actually seen people duplicate a code base and basically cut out different parts of it as they're trying to evolve them separately. That can bring some interesting data challenges along with it, because they usually are still hitting the same database. But there are lots of different kinds of approaches. It needs to be driven by what it is that you most need to change first.
Okay.
Another question? No?
I think I'm standing between them and lunch.
Thank you. Thank you, Rebecca.
Okay, thank you very much. Muchas gracias. One of my other Spanish phrases.